everyone, welcome to the IPLS Academy. Today we are going to perform another experiment in our adulterative series, that is your detection of ammonium salt into a milk. Now before starting the experiment, we have to know that what is this adulteration. So adulteration is simply a process in which a substance are added into a food product to degrade its quality and increase its economic value and the quantity of that product. But when adulteration occurs, the quality of that product are decreases, and even the quality of even the nutritional value of that product are also decreases. Okay, so this is called adulteration, and the substance that is used in this process is always a chemical substance, and that chemicals are known as adulterants. Okay, the FSSAI are strictly inhibited the use of the adulterant. If during the testing they got any adulteration into a product, then that shop are totally banned. Now here the adulterant are what? Ammonium salt are act as a adulterant. Now what is the reason behind the addition of the ammonium salt into a milk product? Okay, so the answer is very simple. The reason behind that addition of that ammonium salt into a milk is only to enhance its density, increase its density. Okay, even when the ammonium salt are added into the milk, then it show a increased lactometer reading, and it also show the richer in protein. Okay, when ammonium salt are added, then it show what? It show a richer quantity of the protein into a milk. But this ammonium salt does not provide any nutritional value. Even the nutritional value of the product decreases. Suppose that we all know that that milk provide a calcium. When this ammonium salt are added, the calcium quantity are decreases, and due to this the bone related problems are increases. That's why it is very important to detect this ammonium salt into a milk product. For performing this experiment, we require three main reagents. The first one is your 5% of the sodium hydroxide. Then second is 5% of the phenol, and the third one is your 2% of the sodium hypochlorite solution. Okay, so how we prepare all these solution? First of all, for the preparation of this 2% of the sodium hydroxide, we required a 2 gram 2 gram of that sodium hydroxide, and it will be dissolved into a 100 ml of the distilled water. Here we prepare it for a 25 ml. So we take a 0.5 gram of the sodium hydroxide and dissolve into a 25 ml of the distilled water. Then we prepare a 5% of the phenol. For the preparation of the 5% of the phenol, we required 5 gram of the phenol, and it will be dissolved into a that 100 ml of the distilled water. Then the last is your 2% of that sodium hypochlorite solution. So this is again, we take 2 gram of the sodium hypochlorite, and it will be dissolved into a 100 ml of the distilled water. This is how we prepare all these reagents. Now for performing this experiment, we required a milk as a sample, test tube, micropipette of 1000 microliter or 1 ml, test tube stand, micropipette tips, and we required a dropper, test tube holder, spatula, and measuring cylinder. Now what we have to do? First of all, we have to take a 1 ml of the sample. into a test tube. Take it. Then after taking a sample, we have to add a 0.5 ml of the sodium hydroxide, 0.5 ml of the sodium hypochlorite, 0.5 ml of phenol. Okay. Then after that, we heat it at 20 seconds inside the water bath, and if a deep blue color are appear, then it means that our sample are adulterant with this ammonium salt. If we don't get any color, then it means that our sample are pure. So I'm going to take 0.5 ml of sodium hydroxide and add into the milk. Then we have to take another chemical, that is your 0.5% of the phenol. If this pink color are turned into the blue color, deep blue color, then it means that our sample contain what? Our sample contain a ammonium salt. If this pink color are persist, then it means that our sample does not contain the ammonium salt. Now I am going to kept it inside the water bath for a 20 second. Okay, the deep blue color that we get if the ammonium salt are present, that deep blue color persists for a 12 hours. Okay, so what we have to do, we have to check it after 20 seconds by taking out of the test tube from that water bath. If the pink color are persist, we don't get any bluish color, deep blue color, then it means that our sample does not contain any ammonium salt. Our sample are pure. Okay, so we are going to take out from the water bath. See that it is still a pink color. We don't get any deep blue color, which means that our sample does not contain any ammonium salt, or you can say that our sample are pure. So this is all about the detection of the ammonium salt into a milk. I hope you will understand, but if you have any query related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms. That is your Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.